Hi, my name is Todd, and I want to talk today about what a tech stack looks like for real-time applications. So jumping right in, when we started PubNub, our vision was, what can we do to make the online world better than the real world? A lot of people are trying to do this. Some people are building VR headsets. Other people build brain-to-computer interaction. What we wanted to do was build the infrastructure that allowed people and devices to communicate in real time over the internet. And deploy that as a network. So basically make it easy to take all these connected devices and have them communicate together better and more quickly. And the ideas behind all of this and the ways we'd like to interact as people on the internet really comes from movies in Hollywood. We call this, or at least I call this, the Hollywood operating system. And it goes back to movies from the early 80s. They all had certain interaction styles, whether we're controlling devices in real time or collaborating or communicating, that really didn't reflect the way we actually used computers back then. But more and more, our online experiences are mirroring the kinds of things we see in Hollywood. And this continues today. Here's a quick clip from a recent movie that shows a lot of interesting things around real-time Hollywood communication.
How do you like this?
Here we see an example of device control.
Remote link has been severed.
And obviously a silly user interface that only exists in Hollywood.
Hi, Ramsey.
More device
Gain
control.
Damn it, she's
Tracking
good.
people in real time on submarines.
They're entering the weapons room.
Oh, that's cute.
Some more device control, closing doors. So obviously lots of silly interaction, and yet our experiences online are reflecting that more and more. And there's two things that happened in 2016 that really have created this big surge. First of all, we hit what I like to call peak iPhone, or at least peak Android phone, and that is we surpassed 2 billion deployed online phones around the world with cheap connections to the internet where people are connected all the time. And the second big thing that happened 2 years ago was this huge decline in the cost of a chipset that lets you build a device that connects to the internet. And that chipset is under $1 2 years ago and much cheaper even now, which means anything, even disposable products, can be connected on the internet. It allows us to control things and see visibility on sensors all the time, everywhere. Now, I like to talk about these experiences as superpowers. As humans, there are three things that this kind of change is allowing us to do. The first is see everything. Now with the internet and with technologies like PubNub, we're expecting our applications to let us see anything, even if it happens half a world away. I want to know if someone crosses through a red light in Jakarta or breaks a window in India, right? I want to be able to be everywhere. That means collaborating in chat applications on dating websites. It means being in part of real-time auctions or racing people on an exercise bike who may be across the country. And finally, control everything. I want to be able to turn on and off lights, door locks, valves, anywhere in the world. And given the fact that we've all seen so many Hollywood movies and we're now connected all the time, more and more we're expecting all of our applications to allow us to do one or more of these things. Now, every day we talk about these things using different words. In terms of being everywhere, we're really talking about chat and collaboration. See everything is more mundanely called real-time updates, real-time tracking things on a map. Imagine seeing taxis on a map or food delivery on a map. And finally, we talk about IoT device control when we talk about control everything. And yet these superpowers, for lack of a better term, are the things that are driving all of these hot trends, these unicorn companies we've seen over the last 5 to 7 years. Whether you're talking about Slack and business collaboration, whether you're talking about Ubers and Gets and Lyfts and companies like that, Grubhub for food delivery, whether you're talking about virtual reality applications, even blockchain, IoT, smart home, dating site, dating applications. These are all enabled by these three superpowers, being able to see everything, control everything, and be part of everything, or be everywhere. So that's all interesting. From a software development perspective, what does it have to do with a software stack? So just a quick history. Really for the last 25 years, all of our software development has been built on this request-response modality where we request an API endpoint, we get back a response, and if we want that information more quickly, like for example chat messages or device status, we generally pull, we just request that over and over again from the server. And as more devices connected to more servers, we realized we need to optimize that. And so for the last, about 10 years, we've been focusing on making our REST stack, our request response stack, faster. So we replaced, Flash with Web 2.0 and HTML5. We replaced the web servers from Apache to Nginx, Node.js, MongoDB on the database side. Cassandra, NoSQL generally. And these are all opportunities and attempts to make the request response stack as fast as possible. But pretty quickly, people realized that it's not just about request response. We need to be able to open up a network connection and stream data to devices when those devices need the data. And so there's been this explosion of protocols and frameworks and infrastructure that attempt to do just that. CoAP and MQTT get talked a lot when it comes about IoT devices, web sockets and HTTP2 and long polling when it comes to just general streaming and so on. But frankly, no matter which system or protocol or infrastructure you use, the challenge is that scaling that infrastructure is pretty difficult. And so as you deploy any of these streaming-based applications, your infrastructure tends to crash and burn. And that's why we launched PubNub back in 2011. That's what was happening at that point. We decided, hey, can we launch a globally distributed communication layer? We call it, just a publish subscribe layer. Work on every device. So we built like 70 SDKs from, iPhones to Android phones to desktops to browsers, even small chipsets for things like clock radios and sensors. And then can we make it so that whatever protocols we use underneath the SDKs, our customers don't have to worry about that. They simply use publish and subscribe and scale from there. And we wanted to deploy it like a CDN. We wanted to deploy this in multiple points of presence around the world. So no matter where your deployment is and where your audience is, you can get the same kind of a quarter-second global latency. We did a lot of security around this, and then most importantly, also provided a 5 nines SLA, which really means that if you lose a data center, no big deal. All of your connections swap over to the next data center, and all of the data is waiting for you because we replicate streams of data across all these different points of presence. Now that worked pretty well, and it meant that people who used to be doing just REST or request response based API calls were able to take a lot of the calls that should be really designed as events, event-based or streaming-based, and turn those into publish and subscribe. So for example, get user data may still be a great request response or REST call, but get chat message, why don't I just open a socket and listen on a channel called chat, for example? If I want to listen for a device status, maybe I should just subscribe to device channel 123 or set the device status. Why don't I publish? And that way, not only does the device get the information, but maybe there are other devices or servers that are curious about control signals sent to a device. And rather than getting inventory when I need it, why not subscribe to an inventory channel that changes instantly under a quarter of a second whenever the inventory number changes in the database? So as we rolled this out, it was very popular, and we learned there were other services people needed, not just publish, subscribe, but storing and playing back those streams. So for example, you could connect to PubNub and pull back using a simple history API the set of data points or streams or chat messages on a channel that had happened the day before or the week before. A next service that people wanted was presence detection. Just like that green dot that appears on Skype when you're logged in, this was another service that lets people just receive a message as soon as a device connects and another message when the device disconnects. People then wanted to take all these published and subscribed streams of data and combine them, multiplex them so you could subscribe to many channels at once, or filter those channels so you can subscribe to just a subset of data coming across a channel, kind of like a where clause on a subscribe statement. And then syndicate those streams. They may want to take those streams of data not just between the applications in their user base, but also take raw streams and sell that data to business partners. So we offer a syndication service. And all of that together really grew our customer base. So we power lots of smart home companies. We power a whole bunch of social companies, lots of food delivery and taxi dispatch companies, and a whole bunch of other real-time applications that have all of those kinds of 3 superpower experiences within them. So that's a big sort of build-up to talk about event-based development and what we've learned so far. While this has been really successful for us, we've stumbled on another challenge, which is that you often want to add business logic in between the messages you publish and the people or devices subscribing. A few examples of that would be things like game logic, chat filtering, geofencing, right? Filtering sensor data or aggregating it, taking votes or sentiment analysis from people, and in real time collecting the results and sending out the summaries. Or a rules engine for things like smart home. If I turn on one light bulb or this sensor triggers open the garage door and things like that. Now, what we see all of our customers do is take all of those data streams, route those down to their servers, process the data on their servers, and publish the results back into PubNub. And the problem with that is it means you need to keep scaling your servers. And even though you may be using a PubNub to deliver data quickly to those end devices, you're still stuck in this world of having to scale your servers in really dealing with low latency situations they weren't designed to handle. And so this sort of bigger trend that's happening is, how can I push that logic out of my servers into a place where the network itself, or at least something above my servers, can do compute? Now, this is what people are generally been calling serverless, where you're taking your business logic, turning it into small containers or small little atomic pieces of logic, and having that run somewhere else. In the case of PubNub, we call it PubNub Functions. And this paradigm is existing everywhere. I frankly don't think it's really serverless, because your server still exists here. Your server is still connected to the network, but it doesn't sit in the middle of all the data streams. It's orchestrating what's happening. So what that means is it's pushing new business rules into the network. It is providing new access tokens or revoking access tokens for devices that have been pulled off the network. So you're orchestrating how the business data flows work, but you're not intercepting all the data flows. And this is really important for applications where low latency or real-time experiences are important. Imagine a chat application where you want to remove the competitor's name being mentioned in any chat room. Rather than filter that down into your servers, just push into the PubNub network, tell it to replace that string, and just have the servers control that logic. In the case of, say, a taxi dispatch application or food delivery service, here you can do a lot of the geo-filtering in the network, the dispatch logic in the network. Maybe your servers are still changing business rules during peak hours, granting and revoking access, but a lot of the low latency application is now being run elsewhere from the servers. Same goes for general rules engines, or tallying votes and publishing the totals months a second. The server may start the voting, it may change the poll questions, but it doesn't actually have to be there doing all of the data flow processing of every single stream of data. And this goes on for game logic as well. Generally, what we're talking about is a new way to think about event-driven development, or really using event-driven development to solve these real-time problems more quickly, getting to market faster, and really eliminating these problems of scale for these real-time data stream-based applications. And this isn't just PubNub talking. Clearly, this is behind the whole move to serverless, whether you're talking about this fog computing movement, or Docker, or Lambda, or Azure Functions, or anything else that's going on. It generally means that infrastructure itself is becoming programmable, which is exactly what we did with PubNub. So a year ago, we launched PubNub Functions, which is a specialized infrastructure, not for all general purpose programming, but for low latency computation, where in under 10 milliseconds, we guarantee that the message you publish will get into your code, and we make sure your code's going to run for a very short amount of time. So this isn't for things like massive big data processing algorithms. It's for filtering, aggregation, transformation, augmentation, things like that, where you're basically in very short order sort of cleaning the data or aggregating the data before it's received on the other end. And with PubNub Functions, auto scales, auto deploy, works globally, and has its own key value store, which really means that you can keep state as messages are going through. Everything as simple as counting the messages, including other business data as well. The last piece to this is event gateways, which means that as you're dealing with data streams, you want to be able to leverage all the goodness that exists inside AWS, inside Azure, inside Google, inside IBM. And so the event gateways allow you to take those data streams, just like we talked about with syndication, and push that data into those cloud infrastructures like Kinesis and Azure Event Hub and so forth. So generally, when we start talking about event-driven development, one of the questions people often ask is, well, we talked about this back in the 90s. There was movements like Corba, and Tibco was coming out with their first pub/sub infrastructure, and there was this movement toward service-oriented infrastructure. So are we really just sort of going back and forth between two different styles of development? And I think the answer is no, we're not. I think that if you look at the way we have to build software for large-scale stream-based applications, application logic has to be distributed everywhere. And what that really means is that as we move forward, you're going to be putting business logic in the devices themselves, in the network and systems like PubNub, in your cloud, and potentially also on-premise. We're really moving to the next generation of the web, where instead of thinking about API-based services and infrastructure, we're looking at event-driven web, where the world is now full of data streams. The web is now full of chat streams and sensor data and real-time graphing and charting, and we really are building our applications to trigger off those events that are constantly operating. And so we're really just in the beginning of this move to the event-driven web. PubNub's a big part of that, but there's a lot more going on there, and something you should definitely take a look at. Anyway, thank you for the time. Really appreciate paying attention to the presentation, and you can reach me at todd@pubnub.com if you have any further conversation or things you'd like to ask. Thanks a lot.